Right, hi guys, and welcome back to a brand new video. Today we're going to be looking at building a CPU emulator in C from scratch. I got the idea from two people, the first being Ben Eater, who somebody commented on my previous videos, and I watched the whole series. I got addicted to it, where effectively he built a computer from scratch using breadboards, the 6502, and other electrical components. And whilst that would have been a fun idea to do on this channel, he's done such a fantastic job on it that I would just be repeating what he's doing. It would probably be fun to show the working components and how it all comes together. But that's just, again, it requires a bit of spending and so on. So I couldn't do that for you guys. But I would strongly encourage you to go watch his channel. I'll put a link up to it somewhere. Or I'll put a photo on the screen and a link in the description if I remember. And the other guy then was David Poo, who effectively created a 6502 emulator in C++. Now, I know it's similar to C, but I thought it would be fun to just, there's a slight difference there. This channel's all about C. So let's give that a go. He effectively worked through this documentation here. It just goes over what the 6502 is. I think it came out in 1975, if I'm right. Of course, I was minus 25 years old then, so never used one in my life, and they're quite rare to come by in the UK, so it wasn't the case of I could just order one and play around with it on a breadboard, sadly. But we're going to look at it. So they've said here on the documentation, my first computer, BBC microcomputer. I think it was also in the Apple II. It was in the Commodore PET. So it's again, it was very cheap as well. I think that was the advantage of it. And it makes a good learning tool because it's an 8-bit processor, so it's very simple and straightforward to get your head wrapped around. Of course, it's single core, so it's much easier to understand the basics to low level what's going on in the CPU. So our plan is then we're going to try and effectively, and again, the people that I've credited, and I'll put a link and a photo to the David Poo's video up on screen now. Again, go support those. I got the idea from them, and you'll see some similarities across both of them in what I say and what I do. So please go show your support for them. That said, we're going to give this a go anyway. So the first thing we want to do is create a main.c file. And we're going to try and do this by using barely any header files, but the only one we're going to use is pretty much stdio.h. We're going to use structs, and we're going to effectively represent memory in the CPU. And we're going to have to do some type defs and so on, just to make things easy to understand. Now, again, I'm a new C programmer, so again, there's going to be some mistakes I'm going to make throughout this, I'm sure, but we'll give it a go nonetheless. So what we're going to do is we're going to create a few type defs just straight off the bat, because I know we're going to have to deal with bytes and words, okay? And I know that because if we go to architecture here, not architecture, although this will come in handy when we set the value for the program counter, which is going to be FFFC, and also then for the stack, which is going to be between 0100 and 01FF, but we'll come back to that shortly. Okay. So we're going to use 16 bits for the register. So that's going to be a word. Okay, so we're going to do that now. Right, so let's create our 16 bits then. This is going to be an unsigned short, and we're going to call that word. And we're also going to do the same then for our unsigned char, which is going to be our byte. Okay, so one is going to be 8 bits long, one is going to be 16 bits long. Now that we've done that, we need to effectively create a struct for the CPU. We're going to use another type def for that, because we have to effectively represent or have a field in our struct that represents the program counter, the stack pointer, the accumulator, the index register X, Y, and also then all of the flags as well. Okay. Now, with regards to these flags, it's just given a particular operation, you'll have to set these flags to a particular value. So we'll worry about that after, okay? And again, if I make any mistakes in terms of my understanding around this, I'm going to try and read through it as we go along, but things, I'm sure I'm going to get some things wrong, but that's fine. So we'll do type def, we're going to do a struct here, and we're going to do, we'll call it SCPU, just so I know what I'm working with. We're going to do word PC. So this is going to be our program. I'm going to use British spelling here and be awkward. Program counter. We're also going to use the stack pointer, which is going to be byte. Now, this is a little bit confusing because it says a byte is 8 bits, but if we go back here to the architecture, it says 0100. So, of course, each of these, their hex values, 2 hex digits is effectively a byte. Okay. So it's a little bit confusing because it means that technically that should be 16 bits, which is a word size. But for now, we'll just call we'll just call her a byte because it's what the documentation say. And I imagine you have to do something with an offset for that, but it's fine. We can come back at a later date. That's fine. So we'll do stack pointer then. So that's our stack pointer. Get rid of these. Don't need them. And then we're going to do our registers now, which are going to be the accumulator, the index register X, and the index register Y. So we can just do this simply by, they're all going to be byte size by the looks of it. So we'll do byte X. Can we just do it like this? Do I get an error? I don't. I do have to come up with a name for this. We're just going to call it CP. We'll just call it CPU. So I don't know if I get any issues with that. I don't. Okay, fantastic. Right. So now that we've done that then, so these are going to be, of course, our registers. And we need something for our flags. And now our flags, I'm just going to call effectively the first letter of whatever it is they are. So that is carry. So we're going to have C. So we'll call it byte C. I think all these are a byte, so we'll do byte C. I don't know if I can I think I can do it like this again. So we'll have C, we can't have Z for 0. Just realized because we've already got byte C. So maybe we could do, what should we call that? We'll just call it ZE maybe. We'll call it I, we'll call it D, we'll call it B for break. We can call this one O, and we'll call this one N. Okay, so I think that's fine. So we have all of our flags, we have all of our we have our program counter, we have our bytes. Yeah, okay, so everything there looks fine. So what we'll do now is we'll create our main function, and we'll just pass void through this because we won't need that. I'm just going to do this. We need to initialize our, or just create our struct. So we're going to call it CPU. In fact, what might be better is if I call this CPU and we do it like that. So maybe I'll just give this all caps, just because it makes it stand out a bit more as to what it is we're dealing with. Next thing we want to do is create memory, but of course we don't have a memory struct yet, so we're going to create that as well. So we're going to do type def struct, and it's going to be called SNEM, and we are going to want to do something here for our memory. Now there's also something else I'm going to need here, which is going to be an unsigned integer 32-bit. So we'll just call it unsigned int, and we'll call it U32. And if I go down here, then we can do something with this. Now, what we want to do, okay, I'll just call this mem. What we're going to want to do is effectively store in here the data. And to do that, we are going to need to define a size for our data. So we can define that down here somewhere. So we're going to do define, and we're going to do max data. And we're going to say it's going to be 1024 bits. Times 64, so that gives us 64 kilobytes, because I believe it says something here, because I was reading it earlier, about holding 64 kilobytes. 16. Okay, we'll just leave it at that for now. I don't think it matters. I'm sure I saw something. Oh, there we are, 64 kilobytes of memory via its 16-bit address bus. Okay, fantastic. So now that that's done, what do we need to store here? Well, we want to store bytes, and we're going to call it data, and it's going to be max data in size. We're going to put that there. So effectively what we're saying here is we're going to have data, which is going to hold an array of byte-sized values, and it's going to go from 0 all the way up to 64 kilobytes. Okay, and that's it. That's effectively the start of our CPU. So the structure seems to be okay there. What we've got to do now is initialize things, and to do that, we'll create something, I guess we could call it, or reboot, I think is what people call it. I'm going off what I've seen before, I think it's reboot. And what we're going to want to pass through there is our CPU, and also we want to pass through our memory as well. So we can do that. We'll create a function called reboot, which is going to return nothing. And we just want to set the values to effectively equal 0. The only things that we will set are the stack pointer and the program counter as well. So we're going to set those. So let's do that now. So we're going to pass through a CPU, and this is going to be a pointer. So we're going to pass through our CPU, and we're also going to pass through our memory as well. So let's do that. Okay, so to do that, we're going to need to effectively look at all of these values up here. So we're going to have a look at our program counter, which is going to be PC, and we want to set, or actually, because we need to access CPU PC, and I'm trying to think how we're gonna have to do a loop. Then we'll do something. We'll run another function inside this function called like initialize, which will loop through the bytes in memory, and we're going to set all of those values to 0. So for now, let's just focus on our CPU. So we're going to set this to 0 X, and this is going to be FFFC, I believe, something like that. And then for this one, the program counter, it's going to be a bit tricky because, well, not really tricky, but we're going to have to just ignore the first 2 digits. So like I said, if we go back here, we can see that the second page of memory is reserved for the system stack, and that is 0100 up to 01FF. The issue that we have, though, is the fact that our stack is 8 bits. So what I'm going to do for now is just call it FF. I think that might be the best thing to do. I don't know if we don't get any issues with that, so I'm just going to do that for now. I might be wrong, but we'll come back to it if I am. Again, this is the first episode. We're not going to get a great deal done. We're just going to get a hard-coded first program up and running. If you guys, should you guys want me to see to continue this series, I'm happy to do it. Okay, but we've got other things we've got to record as well, so I'm being mindful. I'm not trying to let my mouth fall over my back there. But let's try and get the registers up and running now, and all of these are going to effectively store. So we'll have X, which is going to equal 0. We're going to have CPU Y, which is going to equal 0. Yeah, I need to do a semicolon there. And we're also going to have CPU Z, which is going to equal 0 too. Okay, and then under that, we'll just have all of the flags. We'll have CPU C, which can equal 0. We're going to have CPU... hang on. Ah, right. I was wondering earlier, I was thinking, it doesn't sound right. That I'm sure, right, what we can do is use this for Z, and then we'll use, what I'm going to do is add A here. It's the accumulator. I don't know why I was using Z. Anyone who would have picked that up on that now, but I mean, that's fine. It's done. Taking care of it. Right, we have A, we have X, and we have Y. I'm thinking of coordinates. My mind's in gaming land. Right, so that's that then. Right, so we need C, we need Z equals 0. We need CPU. What else do we need? I equals 0. We need CPU. D equals 0. CPU. What are we on? We have C, Z, I, D, B. Again, equals 0. CPU. O. Equals 0. And we'll have one more, which is going to be CPU. N. So that's our negative flag, and we're going to set that to 0 as well. Right, okay. Probably best that I do... Okay, why am I having an error there? Why have I got an error there? Ah, right. It's because I've done all caps. If I do this, and we'll just create a new line there, just so we can separate all of the values, it makes it look a bit more clearer. Okay, I think that's fine now. So we got all of our, we've got our program counter set to a particular address. We have our stack pointer set to a particular address, although that may be wrong. I'll have to double check on that later. We also have our A, X, and Y registers set to 0, and we have all of our flags set to 0 as well. Now, the next step, we're going to create another function inside here, and we're going to call that initialize. and we're going to pass through our CPU. Oh, we don't. Can we just pass through? Yeah, I think we just do this CPU and mem. Oh no, can we just pass through our memory there? I think we can. I think we can because we're only making changes to memory, so that's fine. So what we can do is we're going to call void, and we're going to say initialize, and we're going to pass through mem. We'll call this, and then all we're going to do is for, and we're going to say u32 I equals 0. We're going to do until it reaches max data. We are going to increment I, and after that we just need to effectively set all the values to 0. So what we're going to do is byte. In fact, we don't need to do that. We'll just do CPU, mem data I equals 0. And I believe we have no issues. So that's great. So that's fine. So right now, what we should have up and running is we have our CPU struct, which has all the correct fields. We have our memory struct, which has all the correct fields, hopefully. I may have made some mistakes, but we'll come back to that later. And then we have reboot then, which is going to effectively take in our CPU that we've just created and our memory. It's going to set the program counter to address, set the stack pointer to address. It's going to set all of the registers to 0 as well as all the flags. We're going to initialize memory, which is just creating memory. So we are looping through all of the data in our memory struct and setting all of those values to 0. And that's it. We have effectively set up our CPU ready so that we can do some, effectively run some instructions. Now, the instructions that we're going to want to run are going to be, and this is a good question, because I'm thinking, how are we going to get this up and running? We are going to first create an instruction. We'll just do the first one here. So it's instructions, load, store operations, LDA. So we're going to go down there, and this is what we're going to be doing. So LDA is going to load the accumulator, and there's different types of opcodes we can use. So we have A9, which is immediate, which is what we're going to be doing in this video. So now that that's booted up, we need to create our execute function. So we're going to do execute, and we're going to pass through a few different things here. We're going to pass through our CPU as always. So what we're going to do here, we're going to pass through our CPU. We're going to pass through our memory. And we're also going to pass through a number. Now this number is effectively going to be the cycles, the number of cycles that we're going to run through. So quite literally, whenever we call a fetch instruction, okay, whenever we call fetch, or to effectively from the program counter, we use 1 cycle, okay? So quite literally, we're going to hard code this, but we're going to fetch from the program counter, which will give us an instruction, which is going to be one of these, which is going to be immediate for the first one, because again, we're going to hard code it. Once we've done that, okay, once it fetches that, we're going to have a switch case statement, and inside that switch case statement, in the long run, what you would have is all of the instructions. So all of these for all of load accumulator. Okay, you have all of these different types of instructions that we can run. It's going to effectively go through them, figure out which one we're going to use, and then you're going to call fetch again. Now, it just so happens that this one uses 2 cycles, okay? So again, this one uses 2 cycles. This one runs 3 cycles, okay? I'm not too familiar with what these instructions are doing, okay? I know that they're loading the accumulator, but what they're doing, I don't know, okay? So what we're going to do is we're going to execute the CPU, the memory, with the value of 2, which is going to be the number of cycles. And to do that, we will need to call void execute, and then inside here we are going to, I don't know what I'm doing, we are going to right, we're going to need our CPU, which can be a pointer to our CPU. We're going to need mem, which can be a pointer to our memory, and we're also going to need u32 cycles as well. And what we're going to need inside here is a fetch instruction, which we're going to call. Okay, so that's going to be the first thing we're going to do. So we're going to call fetch. And what fetch is going to do, again, is going to look at the program counter, okay, and it's going to send back the correct byte. Now, I'm wondering, actually, if we should do this inside the while loop, or if it doesn't matter, then we could do it outside, but I think it does matter. I think we're going to need to do it inside the while loop. So we'll have cycles. Well, the cycles is greater than 0. We are going to run this loop, and we are going to fetch some data. And we are going to, I'm just thinking a second, we're going to need CPU for this one. So we're going to fetch CPU and memory, possibly. Yes, we're going to need memory. And let's just get working on our, so this is going to return a byte, and it's going to be called fetch. No, yeah, it's going to be called fetch. We're going to pass through our CPU. And we're going to need our memory, which is going to effectively pass through our memory. No, we're not going to pass cycles through because we can decrement cycles inside just below fetch. So we'll worry about that after. That's fine. Right, so what are we going to need to do then? So we're going to need to access our program counter. So to do that, we're going to need something like mem data CPU PC, and we're going to pass back the data, or the instruction, should we call it? We're going to pass back the, in fact, no, we'll call it data, byte data. So we're going to pass back that. Now what we need to do next is increment our program counter. Is that right? Yeah, I think so. We're going to increment our, well, let's think about what we're doing here. So we're accessing memory data wherever the CPU program counter is. And we'll hard code where the, the instructions so that it'll equal to where the program counter is currently. And we'll worry about that after. So we need to increment the CPU PC. So we'll do that first. And then what we'll do then is return our data. So quite literally, all we're doing is we're returning the program counter, which is going to be the instruction. And then we are going to increment the CPU so it goes to the next instruction or next execution, which is going to be the value in this case. So obviously it's going to be the instruction, which is going to be immediate. And then it's going to go over then into the value that we're going to store there. So that's that. That's that done, actually. I think we're fine now. So we need to effectively say that this is going to be byte instruction. Because the first one's always going to be an instruction. And then, yeah, I'm trying to think what we need to do next. So we need to have, this is where we need to have our switch case statement, I think. And to do that, I haven't done it in a while in C. Switch, okay, so we need an expression, which is going to be instruction. And then we are going to, I keep on doing that. Right, we need to have our case, and our case will be whatever the instruction will be, which is going to be LDA immediate. So what we can do is we can have a little thing up here, which is just going to set what the value is going to be. So we can have const, or is it static const? Static const, I believe. Const byte, and then we'll have instruction LDA immediate. So we'll just call it that for now. Do we get any issues? Yes, we do, because we didn't, I didn't add in the semicolon at the end. So let's just do that. Right, so what we can do then is just add that instruction here. So we'll have LDA instruction, and that's that. Okay, fantastic. So all we need to do now is effectively execute this instruction. The instruction itself, so it loads 10, load LSB, least significant bit, of a 16-bit address into X. Okay, so right, it doesn't really have what we need. We need to do something. So we need to set the value of CPU A to equal whatever the value is going to be. Right, okay. So we need to call fetch again here. So we're going to do byte value, or data, it could be anything. Byte value equals fetch, and then we'll pass through CPU and mem, and that's fine. Then we'll do value here, and then all we have to do is set these next values for the flag. So if this instruction were to be executed, what would happen is the 0 flag would be set to 0 if A is equal to 0. So what we do here is oops, I'm on the browser still. We'd have in brackets CPU. Just realized a mistake I made. CPU. So we'd have CPU A equal to 0. Then we're gonna, right. Yeah, no, that's fine. I think that's fine. I'm just staring at that because I just had a mind blank. We also need to set the least significant bit. So we would do something like wouldn't we do A equals 0, B 1, 1, 2, 3, 4, 5, 6, 7. Do we get an error? We do. What's this expression? Did I type it in wrong? Why have I got an error there? Right, we haven't set it to an actual value. Okay, so this is going to be whatever our opcode is, which is, what is it? A9. Okay, there we go. That should work now. I think that's fine. I don't know if there's anything wrong. I'll come back and look at that shortly. But as of now, I think that's all we need. We've got our value. We've set it to equal to what the accumulator is going to equal to. Something. I was wondering what. I knew there was something wrong there. So Z is going to equal CPU equals 0. And a negative flag. I think that's fine now. I think that's fine. Okay, we'll leave that for now. I think that's sorted, though. I think that's fine. Now that we've done that, I believe we could actually test to see if this is working. So what we can do, just to give it a little go, is we can call printf. And we should add a default value in as well, but for now, I'm not going to add that in. It's something we can add in later. PC is going to be 0x, and then we can effectively print that value. So we'll do CPU.pc. And then if we come down here and do the same, I'm going to have to add a new line. Just realized that. Printf, or printf, PC. That's fine. We don't need to be specific. We know what we're referring to. X, and then we'll have CPU dot PC again. Right. So we'll add in new lines here just so we know what we're on about. So what should happen in theory is the CPU program counter should increment by 2 values. So it's currently at FFFC. We have the stack pointer at FF, which just currently isn't being used at all. So that's fine. That shouldn't matter. But what should happen is every time we're going through, we are... right. Right, let's try this. I don't think it's going to work, actually. I think we're going to have an error, but let's give it a go. Main.c, main, and then we'll do... Yeah, we've got a seg fault. So let's have a little look at this. Right, I've spotted a couple of errors, and I don't know if they're going to resolve the issue. But the first thing that I need to do is resolve the issue of cycles. Okay, so currently I have what do I have? I have an instruction executing here, but I haven't decremented the cycles. We'll do that now. So that's one, and then we also need to do that here as well. Again, I don't know if this is going to fix the issue, but we'll give it a go. So we'll have cycles. We also So something that I've realized as well, here we can see set if bit 7 of A is set. So we'll have to deal with that. I've currently got it so that it's, where did that go? I don't know, that's gone now. LDA. Yeah, so set if bit 7. So if I do this and, oops, what happened there? There we go. And creating the 0. I should do that trick. I think that's all for now. I mean, I need to break as well. So I don't know if that has anything to do with it. Break. And maybe we should add a default value in just so we know where we are with things. So let's do default. And we'll do cycles equals 0. Because otherwise we're not going to get out of that loop. So we need to set cycles to 0. And we'll also break as well. So let's try that now. Give it one more go. Segfault again. Okay, wow, that's interesting. It's always hard to debug it in C when you don't have any information coming back. I'm trying to think what would be best. So we have currently, I'm just trying to check. It's got to be something to do with memory. That's what I'm guessing. So we have, I wonder, because I always have a habit of doing something wrong with the loops. But I haven't this time, because that's meant to be greater than. This is a tricky one then. I don't know how to navigate this, because I don't think I've done anything obviously wrong. I clearly have, but I just don't know where. Debugging always takes longer than... I'm hoping, or what I want to happen, is the program counter should print the current address, should execute 2 cycles. Now I wonder if it's because I haven't set any values. But I don't think that's the case. Okay. Well, we've dealt with those issues, so I don't know what we can do, really. I'm really going to have to just sit down and have a good look at this. Wonder if it's something to do with how I've reset the values. Right, so we have FFFC, which I believe is going to be correct. We have FF for stack counter. We set all the other values to 0. We initialize memory. When we initialize memory, we loop through max member, or max data, sorry. And then we, after that, what do we do after that? So we call reboot, it does that. And then we print, and then after that we call execute. And then when we call execute, we print again. And it's clearly got to be something wrong with execute. That's what I'm thinking. That's what I'm thinking. Right, I'm really going to have to pause this and think, because I don't want the video to drag on too long for you guys. But let me just do some troubleshooting here and I'll figure things out. Right, okay. I is less than. Let's try that now. There we go. I knew it would work. So the question is, no, well, right. So the bug was effectively that I didn't finish off that for loop. So I just said, I didn't give her another condition. So you have to say I is equal to 0 whilst I is less than max data. I just put max data in there. So that was a rookie mistake. But yeah, if we run that, then we can see that we have the program counter, which begins at FFFC. execute one cycle, and then I'll execute cycle D as well then, okay? So that's running, that's working, that seems to be going just fine. Next thing we've got to do is try and hard code some values in here, which will take place before execute, I believe. So we can add that in up here somewhere. So what we want to do is create some sort of operator which is going to set the program counter to a particular value, and that particular value is going to be effectively whatever it is we're executing. So you know, it needs to be universal. So what we can do is pass through our memory, we need to pass through an address, and we need to pass through a value. Okay, so that value could be an opcode or it could be an actual value, and the address is going to be the address as to where we want to store that, which of course will be the program counter. So that will be FFFC and also FFFD as well. Okay, so to do that, we'll just down here somewhere add in mem underscore operator, and we are going to pass through the memory. Oops, not that. Memory, we're going to pass through an address which is going to be 0xFFFC, so that's going to be the first value that we have, and we're going to pass through the instruction or the opcode which we have as an instruction, which is going to be LDA immediate. So that's what we're going to do, and we'll also have then memory, and we're going to do the exact same thing. The only difference now is that we're going to add one to the program counter because execute will do that for us. 0x42. So we're going to store the value 42 into the program counter, and that will be pulled into the accumulator, which we should be able to print out here actually. So of course we haven't created that yet, but if we do printf, we can do something like what are we going to do? Value is, and then we'll have a number which will be, oh, what am I doing? 0x, what am I storing? X, and then it's going to be mem.data, and then the value that we're going to store then, which will be an FFFD. I can't type. FFFD. Okay. Right, so of course this is like just not going to work at the moment. You can see the goal though is that we're going to try and store the instruction FFFC. We're going to store the value that we want to store, or load into the, oh, actually, we don't want to do that, do we? We want to print out the contents of CPU dot, what do we want to, A? Wouldn't that be what we want to store, show? Okay, we'll come back to that. It'll either be, we can just show it straight from memory, or we can show it from, yeah, right, we'll worry about that. Let's just create the memory operator first, and we can just create that by here. So we'll call that mem, oh, sorry. We'll call that, what should we call that? We called it mem operator, so we'll do that. We'll do byte mem operator, and then we'll pass through our memory. We'll pass through an address, which will just be U32, and also a U32 value as well. Right, okay. To do this then, we've got to go to mem.data, and then we want to, the address that we're passing through is one that we want to access, and we're going to effectively put the value in there, and then we're going to return then mem data address. I believe that's right, is it? That was misspelled. Return. Okay. So I think that's fine. So what we're doing there then, we're taking in the memory, we're taking in the address, we're taking the value that we want to store in that said address. So here, for example, we are taking our memory, in FFFC, which is going to be the program counter, we are going to store instruction LDA immediate, load accumulator immediate, and then we're going to then call mem operator again taking our memory, and the next instruction or the next value in the program counter will be 0x42, and we're going to store that there. Okay, so what will happen now then is we've set the program counter, we're calling execute, and if we now I don't know if this will work. Let's give it a go first. I think that might be the best thing to do. Oops. Let's just give it a go. Yeah, there we go. So we can see that the accumulator, so the A register, or the accumulator, I don't know if you call it the A register. What do you call the A register? I don't know. But quite literally, the value that is holding is 42. So it works. So we know that at the moment we've created a CPU, which I know it might not seem overly exciting. Because of course, we haven't got a fully fledged working CPU, but you can see the architecture that goes into it. And I know we can't build a CPU. I mean, you can, not a CPU, but program a CPU yourself. You can do that, but this is just much easier. It's much more accessible for people like us who can't afford those kits, but to build with the breadboards and all that. But hopefully that's exciting. I think the same thing would apply if we did mem, and then we did data, and we did 0x FFFFD. And if we call that then, and we clang that up, and then we run that as well, we get the same value because it's stored in the program counter, which is of course in that particular point in memory. But we also have it stored in the A register as well. So the value is currently held in both those areas. Now, I'm happy leaving it there, but I'm curious if you guys are happy with me leaving it there. So let me know what you think. Let me know if you've enjoyed the video first and foremost, because to create something like this in C, I think is really, really cool, and it's a fun project. And if you were to take it further, you would really get a good understanding of the low-level architecture of the 6502 processor. And because it's friendly, it's single core, it's just much easier to get your head wrapped around things. And I think that can help you in turn then when you come to doing, I don't know, different sorts of programming. I don't know, maybe it's just me, but I just have fun doing this sort of stuff. If you've got any questions, please leave them in the comments below. If you haven't, but you've got some advice or guidance for me, I may have done something wrong here. I've certainly done stuff wrong here because you see I had some bugs, but we got it running. We got something working. Let me know, and I'll address them in the next video should we carry this project on. I noticed people have been asking where the previous C programming videos have gone. The whole idea behind me starting this channel was to show me learning C from start to finish. That is still carrying on, as you can see, pun intended. I want to effectively one day, and again, I do apologize, I've taken those videos down because I feel like they could be done better, and it's just probably me being a perfectionist. I just want to make sure that I redo them. But what I would like to do is quite literally program, give like a C programming course from start to finish, where we just cover the basics and then we work up. I'm not an expert in C, but I know enough about it. I know enough about pointers and memory management and so on that I feel confident in just giving these short little bite-sized videos all in one video. So it could be like a 2-hour-long video, but it's of everything you would like to know in C. For those of you who have commented about those videos, I do apologize that they're not up, but they will be up in some form shortly, hopefully. I look forward to seeing you guys in the next video. As always, if you've got any questions, let me know. Like, comment, subscribe. I'm so glad that we've grown this channel up to over 4,000 subscribers now. You guys are amazing. Thank you for the support, and yeah, look forward to seeing you in the next video. Bye.